Hello, welcome back for our final week of interactive concept presentation. Today we are making kinetic sand. So I already have my two components kind of prepped. So in bowl number 1 here, I have water mixed with dish soap. And then in this one, I have some red sand mixed with cornstarch. So what we're trying to do is make a sand that, just like it sounds, kinetic, you can move around mold, but will return to its first state. So we're gonna hop right in with this. So the key is to add slowly. You don't want to add too much, you don't want to add too little. But we're just gonna pour some in. I'm gonna get my hands in there. Okay, so we're just trying to coat it here. Probably a little too dry. Okay. A little too wet. That's okay though. I think it's gonna hold enough to show what we want to show. Yeah, that's pretty wet. Okay, but kinetic sand. Oh yeah. So this is obviously a little more wet than what I was expecting, but that is my fault for adding in too much liquid. Okay, just gonna wash some of that off real quick while we chat about this. So, like I said, the main ingredients are pretty simple: cornstarch, dish soap, water, and sand. So you may be wondering, why would that be any different than just normal sand? Well, the reason is the dish soap plus the cornstarch creates kind of a barrier or a coating on the sand that allows it to adhere and stick together. So what this does is it creates something called viscoelasticity. And essentially that is something that will hold under stress, but is still malleable under non-stress. So like I said, with kinetic sand, you can kind of mold it to what you want. And then eventually it is going to go back in. Like if you made it into a ball, it will flatten out eventually. But for a little while, it will hold the shape, which is pretty dang cool. Also something cool, it's only going to stick to itself. So that's pretty sticky. But if I took, say, this honey mustard packet, it's not going to stick to the honey mustard packet because the honey mustard does not have the same oil coating. So if I had done it less moist, you would have been able to see I could pull it. That's one of the things that comes with kinetic sand, is like pulling and twisting it and it holding its shape. This is because of polymers. So a polymer is a long repeating change of molecules that gives a stretchy texture. How stretchy it is kind of depends. That'll be based on how long the chain of polymer is. So obviously for this one, a little bit shorter because it wasn't as stretchy as I was hoping for. But it does still have a little bit of stretch. As for the coating, it is considered a silicone. That doesn't necessarily mean it's a silicone, but it does mean that there is silicone-like seals. So the word that I would use for this kinetic sand would be seal instead of oil, because it does kind of seal everything together and promote that bonding that allows it to stay together. One of the other interesting traits about kinetic sand is that it will only stick to itself, like I said, but also it's not going to dry out. It holds very well, and part of that is because of the seal that we get from the dish soap and the cornstarch. So yeah, with that seal you get, increased moisture in there. You have increased surface tension. That's going to be real hard if you try and, pull and put something on it. It's going to not break as easily, which is quite interesting as well. I do think that if you added more of the liquid, it probably wouldn't work. Like we saw with mine, it wasn't as stretchy as a lot of other kinetic sand, mainly because I added too much moisture to it. got a little crazy with that. But all in all, it's a really cool example of how polymers work, how viscoelasticity works. And also it's just a fun thing, especially if you have kids. This would be a great fun thing for them to play with. Super easy materials around the house. So I hope you enjoyed this little presentation and learned something new about kinetic sand.